Now we are going to see about number system in mathematics. What a number system? We can represent numbers in many forms in maths. What are the types of numbers? Now let us see. This is a number line. Okay, this is a center point 0. In right side of this, we can represent these positive numbers. So in front, in left side of this, we can represent the negative numbers. So 0 after positive numbers 1, 2, 3, 4, 5 and so on. And in left side of this, minus 1, minus 2, minus 3, minus 4 and minus 5 and so on. So main concentrate on number line is there are two types, positive numbers and negative numbers. Okay, then other than that we can see other types. Okay, first one is natural number. Natural number is nothing but normally we can say the numbers starting from 1, 2 and so on. Okay, 1, 2, 3, 4, 5, 6 and so on. Okay, wow. And then whole number, second type is whole numbers. So in natural numbers 0 not included, but in whole numbers we can start from it 0, 1, 2, 3, 4, 5, 6 and etc. Okay, this is a whole number. Then type is integer. What is an integer? It is a collection of whole numbers and the negative values of a natural numbers. Whole numbers ஓட collection, whole numbers எடுத்துக்கலாம், natural numbers எடுத்துக்கலாம். Natural numbers ஓட என்ன எடுத்துக்கலாம், whole numbers தான் 0 வருது. So we can start from a 0 to positive side etc. அது வந்து whole numbers. Okay, and then natural numbers ஓட negative side எடுத்துக்கலாம். ஓகேவா, ஸோ இந்த நம்பர்ஸ் லைன்ஸில் பார்த்தோம் இல்லையா, நெகட்டிவ் நம்பர்ஸ். ஸோ அந்த நம்பர்ஸை தான் நம்ம நேச்சுரல் நம்பர்ஸில் ரெப்ரசன்ட் பண்ணியிருக்கோம். ஸோ அதில் வந்துட்டு நெகட்டிவ் ஃபார்ம் எடுத்துக்கலாம். ஸோ -1, -2, -3 and so on. So the collection of natural numbers and whole numbers we can see it as an integer. Okay, then fourth type is fractions. Okay va, it is written in the form of a by b. Okay va, it is nothing but this form is called as a fraction. A by b form is called as a fraction. So a is nothing but numerator means upper part. Okay va, b is a denominator means the lower part. So example of fraction is, okay, 1 by 2, these are all the fraction numbers, 3 by 7, 8 by 3 etc. So 2 by 2, it is not a fraction number. 2 divisible by 2, which is equal to 1. So this is not a fraction. So the which numbers which cannot be divisible, this is called as a fraction number. Okay, and this rational numbers. Okay, so rational number means it is represented in the form of a by b like that fractions, but here the denominator value is not equal to 0. Okay, it is also like that a fraction numbers, but the denominator b value is not equal to 0. Example, uh, eh, for 0.54 not equal to 0. Okay, 0.54, 1 by 5, then it is also as negative values, that means -2 by 5 etc. Okay, this is a rational numbers. Okay, and then next one is sixth one, irrational numbers. Okay, these cannot be represented in the form of a by b. This is not a fraction numbers. Okay, this means root values. Okay, root of 2, root of 3, and then 22 by 7 pi values, etc. Okay, then next one is complex numbers. Complex numbers are contain real and imaginary numbers. Okay, real number means all the numbers, that means, that is, number includes a fraction, integers, etc. Okay, then imaginary numbers. Imaginary numbers are not a real numbers, that is, the numbers when squared will result in a negative number. Okay, that means, in this previous we can see, we have to see that root of 2. Here the negative value root of -1. Okay, so it is a imaginary value. It is represented as a, the imaginary value, the uh, imaginary values in the root we can represent it as I, that means imaginary number. So we can say it is called as a complex numbers. The real and imaginary values are present in the complex numbers. Okay, next we have to see about prime numbers. Prime numbers are not, or that it do not have any factors other than 1. Okay, that means which is not divisible by any number. That means just, for example, 3, 5, 7, other than the 3 by 3 is divisible. Other than that, 3 which is not divisible by any other number. 4, 3 by 4, it contains a fractional, it results comes a fraction, so it is called as a prime numbers. The uh, okay, and then composite numbers, all the numbers other than the prime numbers. Okay, it is called as a composite numbers. Other than the type of prime number means 4, 6, 8, which is divisible by with, for example, take it as 4. 4 is divisible by 2. For take it as 6. 6 is divisible by 6, 4, 2, 3. Okay, so in prime numbers 3 is divisible by only the 3 number. Okay, other numbers, 3 by 5, no, it is not divisible. 5, it is divisible by only 5. It is not divisible by 4, 2, 3, etc. Okay, but composite numbers, 4 is divisible by 2, 6 is divisible by 2, 3. Okay, and then 8 is divisible by 2, 4, 12 is divisible by 2, 4. Okay, it is called as a composite numbers. This is about the basics of the number system. Types of number system. Okay, so what are the types of number system? There are 4 types of number systems. Okay, decimal number system, binary number system, octal number system, hexadecimal number system. Okay, now we have to learn about a decimal number system. What is decimal number system? It means, it says that in suffix we put number 10. Okay, so number 10 decimals. Okay, the in number system with the base value 10 is called as a decimal number system. So 10 numbers, so starting from 0 and ends with 9. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These numbers comes under decimal number system. The place value is termed from right to left as a first place value called as units. That means 10 power 0. Second to the left called as tens. That means 10 power 1. Third to the left called as a hundreds. That means 10 power 2. Fourth to the left called 1000. That means 10 power 3, and so on like this. So example for a decimal number system is, for example, we take it as a number 10285 has place value as, okay, we put it as count from right to left, okay. This is power 0, 1, 2, 3, 4. So we can write as 1. This one we put as this one, and into 10 to the power of 1, 2, 0, 1, 2, 3, 4. So 10 power 4. And then second digit is 0 into 0, 1, 2, 3. So 10 power 3 plus 2 into 10 power 2, 0, 1, 2. So 10 power 2 plus 8 into 0, 1 place. Okay. So 10's place 0. So 10 power 1. So 5 into 10 power, this one is 0th place. So 10 power 4 value is 10,000. 10 power 3 value is 1000. And then 2 squared value is 100. And then power 1 value is 10. Then 10 power 0 value is 1. So anything else power 0 means, that means answer is 1. So we have to multiply these values, okay. So 1 into 10,000, 10,000, 0 into anything 0. So 0 we can write it as, and then 2 into 100, 200 plus 80 plus 5, which is equal to 1, 2, add all these. So okay, 10285, this is the answer. So how it comes, that way this only explain this, okay, with decimal numbers, okay. Then binary number system. So in this binary number system, we have to write in the base as 2, okay. The number system with the base value is 2 is called as a binary number system. So it use 2 digits, okay. Starts from 0 and ends with 1s. So 0 comma 1, only 2 numbers only present, that's why we write it as a base 2, okay. Nowadays in digital electronic sites, the example computer system, electronic devices, etc., etc., it can be easily in this binary number system only use, okay. Converting analog values to digital values, in this digital values zeros and ones are present in the devices, and okay, all other programmings, okay, etc. It can be easily performed using just 2 states, that means on state and off state. 1 means on state, 0 means off state, okay. We can set the program likewise this, the value of 1 is high, the value of 0 is 0, okay. So examples of decimal to binary number system is, so 14, it is a decimal number system, base 10, okay. We have to convert this as a binary number. So 14 is divisible by 2. So divisible by 2 means 7 times 14 remaining 0, again divisible by 2 3 times remaining 1. So again divisible by 2 1 time remaining 1. So what is the binary value for number 14 is 1110, base 2, okay. For this number 19, okay, number 19, base 10. So 19 is divisible by 2, 9 times 18 remaining 1, then divisible by 2 4 times remaining 1, 2 times 2 divisible by 2 2 times remaining 0, again divisible by 2 1 time remaining 0. So what is the value for binary value for number 19 is 10011, base 2, base 2. We have to mention this as a 2. So likewise number 50, for a binary value of number 50 is 1100, 0010. We have to work it as, okay. Work out this octal number system. Then third type is octal number system. Octal means number 8. We have to write as base value as 8. The number system in which the base value is 8 is called as a octal number system. That means starts from 0 and ends with 7. So 0, 1, 2, 3, 4, 5, 6, 7. So total counting is 8 numbers. So we have to base the value as 8. So conversion of octal to decimal. Multiplying each digit with the place value and adding the result. Okay, the place values are here. The place values. What are the place values? Are 8 power 0, 8 power 1 and 8 power 2. For example, 135 for decimal to octal numbers. Decimal to octal numbers. So decimal, what is the decimal number here? 135 base 10 is a decimal number to octal. So what how to convert? So in that binary we have to decimal to binary means it is divided by 2, because binary number is 2. Here octal number is 8, so it is divided by number 8. Okay, so 135 is divided by 8. So one time one is 8, remaining, what is the remaining? 555. So 6 times 48, so remaining 7. So again divided by 8 2 times. Okay, remaining 0. So what is the octal number here? 207 base 8. Likewise we work out this, you have to work out this. 215 base 10. We have to convert this as a octal number. 215 is divided by 8. We have to divided by 8. Then what is the answer? 26, remaining is 7, and then it is divided by 8. What is the answer? 3 times and then remaining 2. So 327 base 8 is a octal number for this decimal number 215. Okay, and then next type is hexadecimal number system. Hexadecimal means number 16. So base value is number 16 is called as a hexadecimal number system. So like decimal system 0 to 9, that means 10 digits. Okay, like that decimal values 0 to 9 we have to write it as the same 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. And then after that 9 we have to write it as 10 as a 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and then 15 as F. Okay, don't write as a 10, 11, 12, 13, 14, 15. Okay, we have to write it as A, B, C, D, E, F. It is used for many address. This type of hexadecimal system is used for many address location in programming. Okay, for example, for this hexadecimal system is what is this? 255 base 10. This here also decimal to hexadecimal conversion. Okay, so before the in that before binary is divided by 2, octal is divided by 8, octal number is 8 here. So here hexadecimal is number 16. So we have to divide this number by 16. Okay, so 255 is divided by 16. What is the answer? 15 times, remaining 15. So what is the value of 15? Okay, value of number 15 is what is? F. So we have to write it as F. F for this F and this for F. So F of base 16. Okay, 1096. Another example, we have to work it out yourself. Okay, and then examples for binary. Before this we already seen about decimal to binary. Here binary to decimal. This one is different from that. Okay. Binary to decimal. So decimal number is what? Here 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7 numbers present here. So decimal means 10. So we have to multiply these digits into 10 power 7. 1 into 10 2 power. Here 2 done. So 1 into 2 power 7. 1 into 2 power 6. 1 into 2 power 5. Here 0 into 2 power 4, 1 into 2 power 3, 0 into 2 power 2, 1 into 2 power 1, 1 into 2 power 0. Okay, and then simplify this. What is the answer coming? 235, the base 10 value. Okay, this is the answer. And then binary to octal conversion, for example. So this is the value of this is the number for binary. So this is divisible by, we have to split it as a 3 digits. Okay, what is it? Here split it as 3 digits. Here 3 digits. Here 3 digits. Here 2 digits only present. So we can write it as a 0. So 0, 1, 1. Okay, 0, 1, 1. What is the value of 0, 1, 1? Already we have to see in that 0, 1, 0, 1, 1. Here what is the value of 0, 1, 1? Before that 0 were nothing else. So what is the value of 1, 1? 3. And then 1, 0, 1. What is the value of 1, 0, 1? 5. Okay, what is the value of 0, 1, 1? 0, 1, 1. That means 3. So 3, 5, 3 is the octal number for this binary value. Okay, and then binary to hexadecimal conversion. So hexadecimal conversion means we have to split it as a 4 digits. We have to split it as 4 digits. Okay, so before 1 is present, so we can put it as a 3 zeros before. Okay, because only one number is present. So before 0 anything before 1 before 0 is not value. So for no confusion we have to put it as a 4 digits. That's why I put it as 30. Okay, so one value is 1. So 1101 value is 1101 value is 13. Okay, 010110 value is 0, 110 value is 6. Okay, 110 here. So before 10 no value. Already I say that na. So 110 value is 6. 1101 value is again 13. So what is the answer for this binary value? 1D. For 13 the alphabetic digit is D. 6 is 6. Again 13 alphabetic digit is D. So 1D, 6D, base value 16. This why is the that's all is the number system. Okay, thank you.